why, because I didn't take calcium today or some reason. And so what is it? What is the measure of the angle that makes the y-coordinate on the unit circle 1? Well, here's where this is the only place where the y-coordinate is 1, and that angle is pi over 2. Okay, so this means that t is equal to pi over 2. All right. But now these trig questions are a little bit sneaky, right? Because we are looking at this function on this interval, right? Between negative 2 pi and positive 2 pi, and that is going to be 2 periods of this thing, right? The derivative is actually going to have, it's periodic with period 2 pi. So in this interval it's going to have 2 periods. Maybe I should draw a picture of this thing. So what does 1 minus sine t look like? So sine t is just sine flipped upside down, and so we're flipping sine upside down and then we're pushing it up by 1. So it's going to be pushed up. Oh, geez, that's terrible. Maybe I should not make dashed lines so that this thing can correct my shaky hands. Alright, and so if this is 1, now what's it going to be doing? Since it's negative, it's going to be going down instead of up. So it's going to go like this. Alright, here, here, here. Okay, so this will be 2 pi. And it's going to do the same thing going in the other direction. Okay, and this is going to be minus 2 pi over here. This is minus 2 pi. And what we just found is the very useful and relevant fact that the place where sine t is equal to 1, or the place where this thing is equal to 0, is right here at pi over 2. Alright, but we have to make sure that we find all the solutions that are in this interval from negative 2 pi to 2 pi, and you can see that there's actually going to be another one right here. Very sneaky and vicious sometimes, these trigonometry problems. Okay, and so, well, look, these 2 points are at exactly the same location in the whole sine cycle, right? So the difference between this thing, whatever it is, and this is going to be 2 pi. So what's going on here is that this point is going to be minus 2 pi plus pi over 2. Okay, and so I just have to figure out what that is, and that turns out to be minus 3/2 pi. Okay, so it's minus 3 pi over 2. So now what we found is that there are 2 solutions. One is t equals pi over 2. Another solution is t equals negative 3 pi over 2. Alright, excellent. So what should we do with that information? Now we are supposed to be finding the intervals of increase and decrease. Alright, and I told you that we were going to find the roots of the derivative and then do some stuff. So now I'm going to deliver on that promise. So let's draw a picture. Well, we already have a picture here. And but how would you do it without the picture? See, I don't know if I'm making things more or less clear when I pretend like there are students who can't get the graph. It's much easier when you have the picture, right? Because you can see that actually for everything that we're concerned about between 2 pi and 2 pi, okay, there are 2 roots. One is this root, which happens at minus 3 pi over 2. And there's another root over here, which happens at pi over 2. Okay, and what we need to know is what is the sign of the derivative on each of these intervals. So let's just look and see. Okay, so we want to ask ourselves, is f prime of t positive or negative on this little magenta strip. So you can immediately see from this picture that I drew over here, it's this is the same, right? You can see that it's going to be positive there. But what if you didn't know? What if you didn't have the picture? Then you would have to find a value in that interval and just plug it in. So you could just find a value in this little magenta piece, plug it in, and check the sign, okay, if you didn't have the picture. Alright, so I'm going to leave that up to you. If you wanted to pick a point in this interval to do a sign check, 0 happens to be in there, so that's very convenient. What happens if we plug in 0 into the derivative? You get 1 minus 0. So that's going to be a positive number. So this is plus. And you can see from the picture here that the derivative is positive on this part. Right? It's positive on this part. And you're probably shouting at me right now, Hunter, can't you see that it's positive on all the parts? You blind fool. And yes, I admit it. It's positive on all the parts. And you could find that out by plugging in points if you didn't have the picture. Alright, so this is kind of an unusual situation. We have plus, plus, plus. Okay. And so what does that mean? That means that f is actually increasing on all of those intervals. Okay. Alright, so I arrived at that conclusion, so I guess now I have to live with it. So the intervals there are no intervals of decrease because this thing is never negative, and the intervals of increase are these things that we're looking at. Okay, so I need some space to write the answer down. I'm going to write it right here. Okay, so the answer to part A here is that f of t is increasing everywhere. So it's increasing on negative 2 pi to 2 pi. Okay. All right. And so it's not decreasing anywhere. And let's go on to part B here. It says, find the values at which the local maximum and minimum values occur. Okay. So what is it that makes, let's say, a local maximum? Okay, so let's look at this. This blue line that I'm drawing here might be a part of a function, and this part right here would be a local maximum. And the way you can tell a local maximum is because to the left of the maximum, the tangent lines are positive. Okay, so to the left we have f prime being positive, but then on the other side of the maximum, the tangent lines have negative slope, and on the right we have f prime being negative. Okay, so how can I tell from this information what local max of the function might be? What I need is some critical number or some root of the derivative where the derivative is positive to the left but negative to the right. Okay, so unfortunately that never happens. Okay, so that means that none of these roots is a local max. But you know that I can still check. I'm on this closed interval, right? So I'm looking for local maximum and minimum values. So none of the roots are going to be local maxima or minima for that matter, but let's think about minima in a second. So none of the roots are going to be maxima, but I can still check the endpoint. Okay, so look, it's increasing this whole time, and so it must be that the maximum is here. The maximum occurs at 2 pi. Okay, so it must be that the only local max, which is also the absolute max, is at t equals 2 pi. Okay, and we can reason similarly about the minimum, right? If it's increasing the whole time, because the derivative is positive the whole time, the only place that has a prayer of being a minimum is this, right? So the only local min, which is also the absolute min, is at negative 2 pi. So the only local min is at t equals minus 2 pi. All right, okay, so that's good. And so what about part C here? It says, find the intervals of concavity and the inflection points. So how much time do we have left here? I might have to start a new video. What does this say? Oh, it's been a while. I'm going to stop this and pick up in another video.